Okay, so we all learn about science in school, right? Biology, chemistry, physics, the usual suspects. But what if I told you there's this entire other field of science that almost nobody ever talks about? One that studies science itself, and honestly holds the key to understanding how we know what we know. So let's dive into the secrets of science. Now, I know it sounds a little strange, but science, the very thing we count on for objective truth, has some pretty big secrets. It's not some flawless machine. It's a human process, and that means it's filled with all these hidden complexities that we really, really need to understand. And here is secret number one, and it is a big one. Just look at this question. Did you know this? Because the answer is pretty startling. More than half, of all the studies that get published, the ones that make headlines and guide policy, well, other scientists can't get the same results when they try to repeat them. Yeah, just let that number sink in for a second. Over 50%. This isn't just a small problem. Researchers literally have a name for it, the reproducibility crisis. It's a huge challenge, and it kind of suggests that a lot of what we think of as scientific fact might be built on some pretty shaky ground. But wait, it actually gets even deeper than that. You see, we almost only ever get to see the successful results. Scientific journals, they love a good, exciting headline, right? This new drug works. But what about the hundreds of other experiments where that same drug didn't work? Well, those tend to stay hidden away in a lab drawer somewhere. This is called publication bias, and it gives us this totally skewed picture of reality where we only ever see the wins. So, with all these issues floating around, you've got to be asking, what's the solution? Well, thankfully, there's a whole field of study that's popped up to tackle these exact problems head-on. And it's time we introduce the hero of today's story. This slide really shows you the shift in thinking we're talking about. On the left, you've got the stuff we all learn in school, the results of science. But on the right, that's the new focus, studying the process of science, the actual engine that creates all those results in the first place.
And that field has a name, Metascience. The definition couldn't be simpler, and I love it. It's the science of science. It is literally science turning the microscope back around on itself to figure out what's working, what's broken, and how we can make it better.
So how exactly does metascience do its thing? Well, you can think of it kind of like a detective. It's not just about random criticism or pointing fingers. It's about systematically investigating the entire scientific process to find the weak spots and shine a great big light on them. And it tackles these huge, tough questions like, why are so many studies failing? How do our own biases sneak in and affect the results? Can we really trust the journals? These aren't just for academics to debate. The answers affect everything, from the medicine we take to the laws we make. It's all about making sure the foundation of our knowledge is as solid as it can be. Now, let's be super clear about something. This isn't some conspiracy theory or an attempt to say science is fake. Absolutely not. Metascience is a movement that's coming from inside the scientific community. It's led by researchers who are dedicated to making the entire system stronger, more reliable, and, at the end of the day, more deserving of our trust. So, if this is so important, why isn't it on the front page of the news? Why isn't it common knowledge? Well, the simple answer is, it makes people uncomfortable. It forces big institutions and individual researchers to look in the mirror and confront some systemic problems that are really difficult and, frankly, expensive to fix. And these are just some of those uncomfortable truths it digs up. We're talking about experiments that were poorly designed from the get-go, a peer review system that's got some serious cracks, and of course, the immense pressure on scientists to publish or perish, which can lead to, well, cutting corners. Metascience looks at all of it without flinching. Okay, but here's where it gets really interesting. This is why all of this matters directly to you. This is not just some internal debate for professors in ivory towers. Understanding these ideas fundamentally changes how you see the world. Because when you get right down to it, knowing about metascience teaches you how to think like a real scientist. And that means going way beyond just memorizing facts for a test. It means understanding the messy, complicated human process of how those facts were discovered and how they might even be overturned one day. And this knowledge gives you what I like to call superpowers. Seriously, you'll instinctively start asking better questions. The next time you see a big headline about some new study, you'll know to ask, hey, has this been replicated? Who paid for this research? Was it just one tiny experiment? It makes you a much, much sharper consumer of information. So what's the big takeaway from all this? Well, embracing metascience isn't about losing faith in science. Not at all. It's about developing a more mature, more realistic, and ultimately a more powerful relationship with it.
I want you to remember this. Science isn't some perfect, unchanging block of facts. It's a dynamic, messy, self-correcting process. And by simply understanding how that process works, the flaws, the biases, the whole shebang, you gain a perspective on the world that, frankly, most people just don't have.
So I'm going to leave you with this question. Now that you're in on the secret, now that you know about the science of science, what's the first thing you're going to question? What headline, what study, what long-held fact are you going to look at with a fresh, more critical eye? Think about it. What will you question first?